Hello friends, welcome to UGC EPG Pathshala module. I am Dr. Rashmi Rani Anand from Shahid Bhagat Singh College, Delhi University. In this lecture, we shall try to understand water resource, distribution, use, pattern and scarcity. The main objective of this module are: first, to describe global distribution of water as oceans and seas, fresh water, surface and ground. Second, to understand the terminology used for groundwater and water cycle. Third, to analyze water resource scenario in India in terms of water availability and usage pattern. Next, to evaluate water scarcity and related problems. Now, let us understand first what is water. Water is transparent and odorless chemical substance and is made up of hydrogen and oxygen molecule. Until the later half of 18th century, scientists believed that water is basic element characterizing all liquid substances. In 1981, the British chemist Henry Cavendish reached to the conclusion that water is a mixture of hydrogen and air. Later, French chemist Antoine Laurent proved that water is a compound of oxygen and hydrogen. In 1804, the French chemist Joseph Louis Gay-Lussac and German naturalist Alexander von Humboldt demonstrated that water consisted of 2 parts of hydrogen and 1 part of oxygen. Now, the present formula of water is H2O. Water constitutes a major portion of living matter as it comprises of 50% to 90% of the weight of living organism. It is a major solvent transporting, combining and chemically breaking down many substances within the living organism for the proper functioning of metabolism. It breaks down essential molecules such as protein and carbohydrates. This process is called hydrolysis. Water also removes waste material from the living being. A large part of animal and plant body consists of water. Water is a vital resource to human and is one of the life supporting layers. It has multiple uses such as in food preparation, drinking, bathing, washing, for plant and animal survival and irrigation. In addition, its large amount is used daily in industrial processes. Now let us discuss about distribution of sources of water on planet Earth. The Earth has abundant water as 71% of total area of the Earth are covered by water. However, its distribution is extremely uneven on the Earth's surface. Out of the total water cover, over 97% is oceanic water and has high salinity and cannot be used. Only 2.5% of water on the surface is fresh, out of which 69% resides in glaciers, 30% underground and less than 1% is located in lakes, rivers and swamps. It means that only 1% of water on Earth's surface is usable by humans and 99% of the usable quantity is situated underground and in glaciers. Now let us discuss about oceans and seas. Oceans and seas constitutes nearly 97.5% of total water on Earth. This huge amount of water has high salinity and is not usable for any purposes. There are total 5 oceans: Pacific, Indian, Atlantic, North and South, Arctic and Antarctic, and they are spread mainly in southern hemisphere. Besides, a number of seas and bays form the major water bodies worldwide. Ocean water is saline and it cannot be used for any human activities. Over the oceans, evaporation is greater than precipitation. So, the net effect of this is that there is a transfer of water back to the atmosphere. In this way, freshwater resources are continually renewed by counterbalancing differences between evaporation and precipitation on land and at sea, and the transport of water vapor in the atmosphere from the seas to the land. Now let us discuss about freshwater. Freshwater accounts for only 2.5% of the world's water supply, which includes 68.7% glaciers, 30.1% groundwater and permafrost, that is 0.8%. Freshwater lakes account 67.4%, wetlands 8.6%, soil moisture 12.2%, rivers 1.6%, atmosphere 9.5% and plants and animals 0.8%. Although freshwater possesses very less amount of water, yet it is essential for human uses such as drinking, agriculture, manufacturing and sanitation. Freshwater is found as surface and groundwater. Now let us talk about surface water resources and groundwater resources in detail. Surface water resources include rivers, lakes, wetlands, etc. Precipitation is the natural recharging sources for the surface water, and it also maintains the hydrological cycle. Human activities like artificial dams, reservoirs are also included in the same category and have capacity to increase utilization of the water. Ice sheets and glaciers are not always thought of as a freshwater sources, but they account for a significant fraction of world water reserves. Nearly 90% of the water in ice caps and glaciers is in Antarctica, with another 10% in the Greenland ice sheets and the remaining in tropical and temperate glaciers. Rivers occupy a relatively small share of fresh water, but they are the large part of the global hydrological cycle and are centrally important in shaping landscapes. A large amount of freshwater flow passes through the world's largest river. For example, Amazon carries 15% of total river flow of Earth. The Congo carries 3.5%. In India, the Ganges, Sindh and Brahmaputra, and in China, Huanghe is the major river system which provide fresh water to more than 50% of the population. Similarly, there are number of river systems worldwide which provide fresh water to human activities. Groundwater resources. Rainwater infiltrates through pores of the rock to form groundwater. Various rivers are primarily supplied by groundwater and in turn provide most of the fresh water discharged to the sea. About 30.1% of global fresh water is found as underground. Groundwater is the second largest available reservoir of fresh water. Millions of people worldwide depends on groundwater stocks which they draw from aquifers, permeable geological formation through which water flows easily. Let us now try to understand major terminology used for groundwater. First is porosity. It is the proportion of void spaces between the rocks within the Earth's surface. In other words, it is the total volume that is occupied by voids. For example, if we take gravel and fill in the bottle, then the spaces within these gravel will be void spaces or the spaces within a pile of marbles. Porosity tends to be larger in well sorted sediments where the grain size are uniform, while in mixed soil porosity or void spaces are generally filled by smaller grains. Soils are less porous at deeper level because the weight of overlying soil packs grains closer together. Next is permeability. It is the capacity of water to flow through the earth's material like sand and gravel. It transmits water based on the size and shape of its pore spaces and how interconnected its pores are called permeability. Materials with high porosity and high permeability are sand, gravel, sandstone, fractured rock and basalt. They form aquifers, low permeable rocks and sediments that impede groundwater flow include granite, shale and clay. Hence, it can be stated that some rocks are porous but not permeable. However, within an aquifer, water often flows upward towards a discharge area. Now, let us discuss about hydraulic head. Hydraulic head within an aquifer determines that where and in which direction groundwater will move. Hydrologists use this to understand and map the complex pattern of groundwater flow. Thus, the hydraulic head at a point is simply the elevation of water that rises up in a well open to the aquifer at that point. Depending on local rainfall, land use and geology, streams may be fed by either groundwater discharge or surface runoff, direct rainfall or by some combination of surface and groundwater. Perennial streams and rivers are primarily supplied by groundwater, referred as base flow. During dry period, they are completely supplied by groundwater. During storms, there is a direct runoff and groundwater discharge also increases. Now, we shall try to understand the process of water cycle. All the water on the earth is connected through water cycle. The cycle begins with the evaporation of water in the form of water vapor from the water bodies. The water vapor rises in the atmosphere, forms cloud and condensation takes place, and then after precipitation takes place. This is also helpful in maintaining ecosystem. In this process, water moves from one reservoir to another, such as from river to ocean or from ocean to the atmosphere by the physical process of evaporation, condensation, precipitation, infiltration, surface runoff and subsurface flow, and it is called water cycle. Water cycle or hydrological cycle is an important process of the land and atmosphere which brings rain on earth and support life on earth. There are main 4 stages in the water cycles, which are also called components of water cycle. They are evaporation, condensation, precipitation and collection. When warmth from the sun causes water from ocean, lakes, streams, ice and soils to rise into the air and turn into water vapor, it is called evaporation. After reaching to the troposphere, which is a cool layer of the atmosphere, water vapor becomes cool and condensed, and that leads to the formation of cloud. This whole process is called condensation. Then water falls from the sky as rain, snow, sleet and hail, which is called precipitation. The water sinks into surface, also collect into lakes, oceans or aquifers. It evaporates again and continues the cycle. The fundamental characteristics of the hydrological cycle are that it has no beginning and it has no end. Solar radiation drives evaporation by heating water so that it changes to water vapor at a faster rate. This process consumes an enormous amount of energy, nearly 1/3 of the incoming solar energy that reaches Earth's surface. On land, most evaporation occurs as transpiration through plants. Water is taken up through roots and evaporates through stomata in the leaves as the plant takes in CO2. For example, a single large oak tree can transpire up to 40,000 gallons per year. Much of the water moving through the hydrological cycle involves plant growth. However, it has to be noted that since evaporation is driven by heat, it rises and falls with seasonal temperature. Water also evaporates through transport-evaporation on land. The soil absorbs water, and when it gets heat, evaporation takes place. This process is called evapotranspiration. The hydrological cycle is also associated with material cycle on the earth as rainfall erodes and weathers rock. Weathering breaks down rock into gravel, sand and sediments at its own place. It is also an important source of key nutrients such as calcium and sulfur, while erosion always involves agents like rain, wind, water, etc. Water being an important agent, it is estimated that from rivers about 17 billion tons of material are transported into the oceans each year, of which about 80% is particulate and 20% is dissolved. Let us now see water resources scenario in India. In India, rivers are the major sources of water. Here, utilizable annual surface water in rivers of the country is 690 cubic kilometer. Groundwater is other major source of water which is recharged from the precipitation mostly in the monsoon season. The annual potential of natural groundwater recharge from rainfall is about 342.43 cubic kilometer, which is 8.56% of total annual rainfall of the country. Irrigation system includes canal irrigation, which also contributes in the recharging of the groundwater. The annual potential groundwater recharge augmentation from canal irrigation system is about 89.46 cubic kilometer. Water is a very scarce and polluted in most of the Indian cities. On the other hand, rural areas too are facing low quality of water. A large part of India is facing water scarcity mainly during the summer season, which includes Rajasthan, part of Madhya Pradesh, Maharashtra and Gujarat and southern states. It also observed that large part of India experiences drought and flood-like situations simultaneously. Now let us discuss about water availability and use pattern. Out of the total water available globally, about 97% of water is saline. Therefore, fresh water supply is certainly limited and accounts for only 2%. Currently, from 10,000 to 12,000 cubic kilometers of fresh water are available for human consumption each year worldwide. In the year 2000, humans withdrew about 4,000 cubic kilometer from this supply. About half of the water withdrawn is evaporated, transpired by plants or contaminated beyond use, and so became temporarily unavailable for other users. The other 50% was returned to use. For example, some water used for irrigation drains back into rivers or recharges groundwater, and most urban wastewater is treated and returned to services. Of the water withdrawn for human uses, 65% went to agriculture, 10% to domestic use like households, municipal water systems, commercial use and public services. 20% to industry, that is mostly in electric power production, and 5% evaporated from reservoirs. It can be stated that both population levels and economic development are important drivers of world water use. If current pattern continue, the World Water Council estimates that total yearly withdrawal will rise to more than 5,000 cubic kilometer by 2050 as world population rises from 6.1 billion to 9.2 billion. During the 20th century, world population tripled, but water use rose by factors of 6. The United Nations and the international community had set goal of halving the number of people without adequate safe drinking water and sanitation by 2015. Now we shall discuss water scarcity. Water scarcity can be defined as the point at which the aggregate impact of all users encroaches on the supply or quality of water under prevailing institutional arrangements to the extent that demand by all sectors including the environment cannot be satisfied fully. One of the main problems that is faced by the world's society in the 21st century is water scarcity. In comparison to the last century, water uses has been growing at more than twice the rate of population increase. A number of regions are increasing with chronic shortage of water can be seen. Every continent is facing water for that matter. Almost 1/5 of the world's population, around 1.2 billion people, live in areas of physical scarcity, and nearly 500 million people are on the verge of water scarcity. Some countries lack the necessary infrastructure to take water from rivers and aquifers. About 1.6 billion people, that is almost 1/4 of the world's population, is facing economic water shortage. On the other hand, a large amount of water is wasted, polluted and unsustainably managed, and thus we can conclude that water scarcity prevails due to the factors both natural and human. Worldwide, about 700 million people in 43 countries suffer from water scarcity. By 2030, almost half the world's population will be living in the areas of high water stress, including between 75 and 250 million people in Africa, mainly due to climate change. This figure may increase in the sub-Saharan Africa. Coping with water scarcity. Worldwide, the UN has launched awareness program through observing World Water Day to combat desertification. Expansion of agriculture, damming means here construction of dams, diversion, overuse and pollution threatens water resources in many parts of the globe. It is the greatest challenge to the government to provide safe drinking water for more than 1 billion people who are suffering from water scarcity. Particularly developing countries, safe water free of pathogens and other contaminants is unavailable to much of its population, and water contamination remains a concern. Even it is challenging for developed countries with good water supplies and advanced treatment systems. Overdevelopment, especially in coastal regions and areas with strained water supplies, is leading many regions to seek water from more and more distant sources. I hope you all have heard about water wives concept, which was documented by BBC also. And this concept is about India, villages in Maharashtra which have water wives and their prime job is to carry water. In a city also where water is used for cleaning, manufacturing and sanitation, per capita use is around 150 gallons per day. There are many factors affecting the prevailing water scarcity in the world, and they are as follows. First factor is depletion of water resources. Water resources, both surface and groundwater, are depleting at an alarming rate worldwide. The reasons are many. However, 3 reasons are prominent. The first factor responsible for depletion of water resource is mounting population. Second reason is pollution, and the third cause is climate change. Now let us discuss water salinization as the factor of prevailing water scarcity. Water salinity is increasing in many parts of the world due to influence of several factors. Among them, the main factors are prolonged drought, less rainfall and excessive use of surface water. When the fresh water resources become saline, they can no longer be used for irrigation or drinking. Saline water is toxic to plants, and high sodium level concentrated in water is very hard for the plant. Irrigation from this water becomes toxic to most plants due to high concentration. Third factor for depletion of water resources is water pollution. Different types of contaminants can pollute water and make it unusable. Pollutants of drinking water include harmful microorganisms such as fecal coliform bacteria, disinfectants and water disinfectants byproducts including chlorine, bromate and chloride. Inorganic chemicals such as arsenic, cardamom, lead and mercury. Then next is organic chemicals such as benzene, dioxin and vinyl chloride. Radionuclides including uranium and radium. Surface water, rivers, lakes, wells are highly polluted mainly in the developing countries, and their water is not usable, which leads to further scarcity of water. Development in all sectors and establishment of industries are the major causes of water pollution. Fourth factor for depletion of water resources in waterborne diseases. More than 2 million people die each year from diseases such as cholera, typhoid and dysentery that are spread by contaminated water or by lack of water hygiene. Cholera, typhoid and dysentery are caused by drinking water containing infectious virus or bacteria, which often come from human or animal waste. Skin and eye infections are caused by lack of clean water for washing. The developing countries are facing this problem largely. Now let us discuss about impact of climate change on water scarcity. Climate change has a great impact on global water resources. As temperature increases, evaporation increases, sometimes resulting in droughts. In addition, rising temperature is melting glacial ice, which are the major sources of fresh water. Receding glaciers are the most important phenomena due to rising temperature, which is leading to water scarcity. Climate scientists predict that there will be a profound impact on climate change on the hydrologic cycle, and that in many cases these effects will make existing water challenges worse. Rising global temperatures will alter rainfall patterns and making them stronger in some regions and weaker in others. Already we are facing such problems, and many make storms more frequent and severe in some areas of the world.
Excellent.
Concluding this module, we can state that water is a precious and scarce resource. As oceanic water covers about 97% of the total water volume and it is saline, it cannot be used for any human activities. A large volume of fresh water is located as ice cap and in Antarctica and Arctic, which is also unused. Further overuse and high pollution in freshwater resources create acute water scarcity worldwide. As a result, many countries of the world are facing acute shortage of water. If this situation continues further, it will have devastating consequences. Therefore, conservation of water for larger interest of humanities is inevitable. Thank you.